So now we will discuss a simple problems in a diesel cycle. Determine air standard efficiency of a diesel engine having cylinder bore 250 mm and stroke 375 mm with a clearance volume of 1500 cc. 1500 cc. If the fuel cutoff occurs at 5% of swept volume. Assume gamma is equal to 1.4. So now we will draw the PV diagram. This is the PV diagram. Let us mark the diesel cycle. 1 to 2 is a compression process. 2 to 3 is heat addition. 3 to 4 is an expansion process. 4 to 1 is a heat rejection process. Now, so this is PV, power gamma is equal to constant, P is equal to constant, heat supplied, and PV power gamma is equal to constant, and here V is equal to constant, heat rejection. Let us mark the clearance volume here, Vc, this is V2, and this is the swept volume Vs, and this is V3, and this V1 is equal to V4. So with these data, with this information, let us start writing the given data for the given problem. The cylinder bore is 250 mm, so D is equal to, we can write 250 mm, that is equal to 25 cc, 25 cm, and L is equal to 375 mm, that is equal to 37.5 centimeter, and clearance volume is equal to 1500 cc. The fuel cutoff takes place at 5% of the swept volume. Okay, cutoff takes place at 5% of swept volume. So now we have to find out, and gamma is equal to 1.4, it is given, and we have to find out the thermal efficiency or air standard efficiency. You can say air standard efficiency. Assumption, air is the working medium. assumption air is working medium. Now we will start giving the solution for the given problem. So first try to find out what is Vs, swept volume. Swept volume Vs is equal to pi by 4 d square L, that is equal to pi divided by 4 into 0.25 square into so we can write in terms of centimeter. So 25 square into 37.5. So you will get shift pi divided by 4 into 25 square into 37.5. So you get 18,407.77 cc, centimeter cube. And what is the volume V1, initial volume, is equal to, and if you look at here, V1 is this volume, Vc plus Vs. Vn is equal to Vc plus Vs. Vc is 1500 plus 18,407.77 cc. So 1500 plus 18,407.77, you get 19,907.77 cc. Therefore, compression ratio is equal to V1 by V2. So V1 is 19,907.77, V2 is 1500. So you get divided by 1500 is the clearance volume. It is given Vc, that is equal to V2. So you get now the value 13.27. Now we have to find out the V3 value. V3 is equal to Vc. So we have to find V3, that is Vc plus 5% of Vs, that is equal to 1500 plus 0.05 into 18,407.77. So you get now 0.05 into 18,407.77 plus 1500. You get 2420.39 cc. Now the cutoff ratio is equal to V3 by V2 is the cutoff ratio. So V3 by V2, that is equal to 2420.39 divided by 1500. So 2420.39 divided by 1500 is 1.614. This is the cutoff ratio. Now we have to find out the air standard efficiency. Air standard efficiency for a diesel cycle is equal to 1 minus rho power gamma minus 1 divided by r power gamma minus 1 into gamma into rho minus 1. So we have to substitute the values. 1 minus the rho value is cutoff ratio, is the rho value, and compression ratio is the R. So rho value is 1.614. So 1.614 power 1.4 minus 1 divided by the compression ratio is 13.27. So 13.27 power 1.4 minus 1 into 1.4 into the rho value 13.27 minus rho value is 1.614. So 1.614 minus 1. So you will get now 1.614 over 1.4 . So air standard efficiency is equal to 1 minus rho power gamma minus 1 divided by r power gamma minus 1 gamma into rho minus 1. So now we have to substitute the values of rho, gamma and r. Rho is cutoff ratio, that is equal to 1 minus the cutoff ratio is 1.614. So 1.614 power the gamma is 1.4 minus 1 divided by R value compression ratio is 13.27. So 13.27 power 1.4 minus 1 and gamma value is 1.4. So into 1.4 into rho minus 1, rho is 1.614 minus 1. So now we have to calculate the values. So 1.614 power 1.4 minus 1 divided by 13.27 power 0.4 divided by 1.4 divided by 0.614 to 1 minus answer is equal to 0.6052. So that is equal to 60.52 percentage is the air standard efficiency. So air standard efficiency is 60.52 percentage. So this is the PV diagram for a diesel cycle. We will solve another problem in a diesel cycle. A diesel engine has a compression ratio of 18. The fuel cutoff is taking place at 5% of stroke volume. Find thermal efficiency of diesel engine. So we know this is the PV diagram. So PV diagram 1 to 2 is a compression process, isentropic compression. 2 to 3 is a constant pressure heat addition. 3 to 4 is a isentropic expansion. 4 to 1 is a constant volume heat rejection. So this is clearance volume and this is a swept volume. Now We will write the given data first. Given data, the compression ratio R is equal to 18. The fuel cutoff is taking place occurs at 5% of Vs. Determine thermal efficiency. So we have to find thermal efficiency. And the assumptions are air is the working medium. Air is the working medium. Therefore, gamma is equal to 1.4. Now, we will solve this problem. Solution. And we know compression ratio R is equal to V1 by V2, and from this 18 is equal to V1 by V2, and from this we can write V1 is equal to 18 times of V2. Now we have to find out the swept volume, is Vs is equal to, and if you look at here, the Vs is V1 minus V2, right? So this is V2 and this is V1. So the swept volume is V1 minus V2. So that is equal to V1 minus V2. V1 is 18 times of V2 and V2 is simply V2, we can write 17 V2. So now we have to find out what is V3. V3 is equal to V2 plus 5% of, that is 0.05 times of Vs. So this is V3. So V2 plus 0.05 times of Vs. So V2 plus 0.05 times of Vs is actually 17 V2. So 17 V2. We get now V3 is equal to, right, and I can write here itself V3. So 0.05 times into 17 is 0.85. So 1.85 V2. So now we have to find out what is the cutoff ratio. The cutoff ratio is equal to V3 by V2. So 1.85 V2 by V2, because V3 is 1.85 times V2. So we get 1.85. This is the cutoff ratio. Therefore, now the efficiency of a diesel engine is equal to, we know, 1 minus rho power gamma minus 1 divided by r power minus gamma 1 into gamma into rho minus 1. So substitute everything, the values what we know, that is equal to 1 minus 1.85 power 1.4 minus 1 divided by r value is 18. So 18 power 1.4 minus 1 into 1.4 into rho minus 1, therefore 1.85 minus 1, okay, rho minus 1. So that is equal to now, so 1.85 power 1.4 minus 1 divided by 1.8, now it divided by 18 power 0.4 divided by 1.4 divided by 0.85, you get 0.3 3613. Therefore, thermal efficiency can be informed as 36.13 percentage. Right. So, in this problem, the thermal efficiency is determined as 36.13 percentage. So, after calculation, the value is 0.6387, that is equal to 63.87 percentage. Therefore, thermal efficiency of a diesel engine is equal to 63.87 percentage. Okay. So, we have determined the thermal efficiency for the given problem. We will discuss another problem in diesel cycle. An air standard diesel cycle has a compression ratio of 14. The pressure and temperature at the beginning of compression stroke are 1 bar and 300 Kelvin. The maximum cycle temperature is 2500 Kelvin. Find cutoff ratio and thermal efficiency of the air standard cycle. So, let us start with the given data. For the problem, you have to write given data. The compression ratio is 14, R is equal to 14, and pressure at the inlet is equal to 1 bar, and temperature at the inlet is equal to 300 Kelvin. The maximum cycle temperature T max, that is equal to T3, because in a process 2 to 3 only the heat is supplied. Therefore, the third state will have a maximum cycle temperature. Then find cutoff ratio and efficiency of air standard cycle. The assumptions are air is working medium, therefore gamma is equal to 1.4. I'll start with solution. We know T1 and we know R, therefore we can find out T2 is equal to T1 into R power gamma minus 1. So, T1 is 300 and R is 14 for gamma 1.4 minus 1. So, now we have to calculate the T2. So 300 into 14 power 0.4 is 862.13 Kelvin. So now we have to find out the cutoff ratio to calculate efficiency. The cutoff ratio is equal to, so V3 by V2 is a cutoff ratio. Since 2 to 3 process is a constant pressure process, V3 by V2 is equal to T3 by T2. So cutoff ratio can be found out using the ratio T3 by T2 also. So T3 is 862, T3 is 2500 Kelvin and T2 is 862.13, that is equal to 2500 divided by 862.13, you get 2.9. So this is the cutoff ratio. Now we have to find out the efficiency of a air standard cycle. So efficiency of a air standard cycle is equal to 1 minus rho power gamma minus 1 divided by r power gamma minus 1 gamma into rho minus 1. So we have to substitute the values. 1 minus rho is 2.9, so 2.9 power 1.4 minus 1 divided by the compression ratio is 14, so 14 power 1.4 minus 1 into gamma 1.4 into rho 2.9 minus 1. So we have to calculate this value. So 2.9 power 1.4 minus 1 divided by 14 power 0.4 divided by 1.4 divided by 1.9. So we get the answer 55%. So 0.55, that is equal to 55%. So efficiency of a air standard cycle is equal to 55%. 55%.